I'm going to do now is kick over to geometric sequences. On page 29, we'll skip the do now and just go right to it. The process here is nothing too crazy. Right, so the sequence is given, but it's given in a different form. Because if I add to get from 2 to 6, I'd have to add 4, right? But am I adding the same number, 29, to get from 6 to 18? No, I'm adding a different number. So adding 4 and then adding 12. And then adding something much bigger, like 27 or something. 26 maybe? Bottom line is, it's not arithmetic, so it's got to be something else. All right? So you're going to multiply by a common ratio to get from one term to the next. All right, so with that in mind, what did I have to multiply 2 by to get 6? What did we say? Sorry? 3? Is it the same, 6 to 18? 18 to 54? So what's the next term in this? 162. All right, so geometric sequence is most closely aligned with an exponential function. Because if you know the start value and the common ratio, then you have pretty much what you need in order to define your function. All right. So in the case of number 1, what am I multiplying by? -5. So the next term in the sequence would be what? -500 followed by 2500. All right, so r is -5. What about the next one? 1/2. So 2 and then 1, right? All right, so in terms of a practical approach, a sub 1 is what it's always been, initial value. Common ratio, also known as a multiplier. And n is still the term in the sequence. All right, so structurally, yeah, the formula looks a little different. But in terms of what makes up the formula, not too much different. It's just we're not adding to get from term to term, we're multiplying to get from term to term. All right, so the explicit formula, it's not going to be bad because all I'm going to do is start with my initial value. All right, I have 5, so that's my a sub 1. The r value is 2. So my recursive formula here would be a sub n 5 times 2 to the n minus 1 power. Now, how does this differ from what we did in the calculator for arithmetic sequences? Well, not really very much at all, right? But I think with time being what it is, I think it's a conversation for a different day. But we can test it out pretty easily. Because if I plug in an n value of 1, I get a power of what? So yes, I am really asking you to take 1 and subtract 1 from it. 0. 2 to the 0 power is?
1.
1 times 5 is? 5, that initial value. So then take another test value, like 4. Plug in a 4, you get a 3. 2 to the 3rd power is? 2 to the 3rd is? 8 times 5 is? 40. All right? So test it for a few values and see what you come up with. And if you do that, you're going to be in pretty good shape. When it comes to recursive models, you could actually go, once you've generated the model itself, you could come up with an equation in terms of x and y and just type that in and go to the table the old-fashioned way. But when it comes to something that's defined recursively, specifically recursively, with the a sub n minus 1 still in it, then that's a different story. But this is an explicit formula, not a recursive. I think I might have said recursive before, but it's an explicit formula. All right, so all of these other problems are along the same lines. So I don't think, oh, we do have to define one last thing where n is greater than or equal to 1. Now, you don't always have to define this. I'm just doing it at least for this one case, just to indicate how things are working for this particular function. Because if I wanted to start with a 0, I'd get a negative power. That doesn't really make sense in this context. If I start with a 2, like we did in a recursive formula, I would get a 10. That would be my second value. So it's a little bit different. Like I said, it's the assumed value of n greater than or equal to 1. You don't have to write it every time, but you should at least be aware of it. All right. On the next page is where the recursive stuff comes into play. So look at the structure and compare it to what we did before. If you even remotely understood what was happening before, this is nothing. Remotely, ever so slightly. We have an a sub n and a sub n minus 1 that are built into the formula. You don't have to change those things. For arithmetic, we were adding the changing value. So whatever it was, the d value in that case, we were adding it. Here we're multiplying by the r value, which is the value that we use to change from term to term. So in the case of number 8, we have our start value, a sub 1, which is 5. They're telling us that each term in the sequence is going to be negative 4 times the previous term in the sequence. All right? So, again, this is the previous term. In the sequence. So what would my second term be? The previous term is, yeah, it's going to be negative 20. The previous term was 5. We're multiplying by negative 4, so negative 20. Then we have an 80. 4, and then what, negative 320? All right. But then you say, okay, well, that's all well and good. I'm not going to remember that the day of the test. I'm not going to remember that the day of the Regents. I mean, that could happen. You got to remember something. So whether it's what that stuff means or how to do it on the calculator, you got to remember something. Because this, based off of our function notation, can also be written. This is the same as saying f of n is equal to negative 4 times f of n minus 1. So same as. The one thing I don't like is that the TI, the calculator, changes the notation and makes it u. I feel like that's kind of unnecessary. All right. But this is what you would type in, and you change your mode to sequence mode. That's what you would type in if you wanted to get all these values without doing the work. All right. So let me actually do the on the big screen, the streaming calculator.
I get it. What is where n is greater than 2 have to do?
If n were, n has to be greater than or equal to 2, because if you plug in a 2 for n, that gives you a 1. So that means that the earliest value that you'd be working with would be the first term. Whatever makes it equal to 1. Yeah, so if this were like n minus 5, then n would have to be 6 or better. Because it has to be a result of 1 to give you that first term. All right, so the sequence function again. So go into mode sequence. type in your recursive model. So in this case, it's -4 times u. So I'm using the older calculator, so second, 7, n minus 1. I'll clear this out and replace it with my start value, which was 5. All right. Once I do that, I have it the way I want. I go right to the table. All right. I'm down to 7, so, well, I didn't want to start there, so let me go back. My first value is 5, -20, blah, blah, blah. After a while, the numbers get pretty big. Do you want to do these calculations? Probably not. If I needed the 15th value, I could just scroll right down to it and write it down and call it a day. All right? Again, it's a luxury. If you like it, use it. If you don't like it and you hate it, pretend none of this happened. No, give me now.